Okay, Newton's first law of motion cannot be omitted. Because Newton's first law of motion, it is the only law which can explain about inertial reference frame. You cannot explain about inertial reference frame using second law or third law, but using Newton's first law of motion. So Newton's one among the most significance of Newton's first law of motion is that it explains about inertial reference frames. Okay, although Newton's first law of motion is the special case of second law, it cannot be omitted because it is the only law which can explain about inertia reference frames. Inertial reference frames. For instance, a person inside a moving car observes objects, for instance trees outside the car moves backwards with relative motion because of reference frame. The reference frame of the person inside the car is moving. That is why the person observes objects outside the car moving too. However, a person outside the car observes the trees at rest because his frame or her frame is at rest, not moving. So the law which can explain about inertial reference frame is Newton's first law of motion. That is why we can't omit or eliminate Newton's first law of motion, although it is a special case of Newton's second law of motion. Yes. Okay, before we continue with the applications of Newton's second law of motion, let us check the definition of Newton's third law of motion. Newton's third law of motion, this law stated that to every action there is an equal and opposite reaction. To every action there is an equal and opposite reaction. There is an equal and opposite reaction. Now suppose I pinch my fingers. I feel pain because of reaction force. When I apply force to the wall, that is an action. A reaction given by the wall, the result is pain. Another example is when we fire the bullet from the gun. The boot of the gun moves backward as the bullet gets out. The action there is firing the bullet. The reaction result is backward movement of the boot of the gun. Another example is when somebody jumps out from the boat. The boat itself moves backward. That is Newton's third law of motion. There are so many examples. Or a book, for instance, a book on a table. A book on a table. A book on a table. This one. The weight of the book applies an action on the table, while a reaction force offered by the table surface R, reaction force R. Okay, for the book to remain on top of the table, its weight should counterbalance the reaction force R. So mathematically, quantitatively, Newton's third law of motion can be written as the net force F is equal to negative net force F. This one is an action force, and this one is a reaction force. To every action, there is an equal and opposite reaction. If you apply an action, remember there is an equal in magnitude, a reaction offered upon you. Okay. Now, for instance, if this is an action, this one is a reaction. For instance, if this is an action, this one is a reaction. Number one, firing of the burette from the gun. Firing of the burette from the gun is an action. Now, what is the corresponding reaction? The corresponding reaction is backward movement of the boot of the gun. Suppose if this is the gun, if this is the gun, if the bullet gets out from the gun, the bullet, okay, when the bullet is fired, that is an action, and leaves the gun with the force F. However, the reaction is negative F, which is the backward movement of the boot of the gun. So, action force F is equal to negative reaction force F. That is Newton's third law of motion. However, the question is that if action and reaction are the two forces equal in magnitude but opposite in direction, so why don't they cancel each other and leave no net force on an object? Why? Why can't they cancel each other so that there is no net force on an object? Nice to meet you again. Welcome to the next lecture. But don't forget to subscribe, to like, to comment, and to share. Simon Shija Wanga, PM Classroom. Welcome.